Hello and welcome to my Genetics 311 Module 3 exam video. Today we're going to be talking about chromosomal crossovers during meiosis and how these affect gametes. So how does a crossover happen? A synapsis is when two chromosomes pair during meiosis. It allows the matching up of homologous chromosomes prior to their segregation and separation during meiosis 1 and 2. Sometimes chromosomal crossovers occur between them, and that's the sharing of genetic information, and resulting gametes can be viable or inviable. So a viable gamete would have all the loci and genetic information, no duplications, no deletions, and a centromere. So today we're going to be looking at two organisms, and the first one is going to have this genetic sequence, MIJ, centromere K, L, H, and G. And as you can see, they're very similar, but we just have a flip in the middle. That's called an inversion, a pericentric inversion, because it involves the centromere. So when these line up, they need to maximize their pairing. And to do that, they're going to create a pericentric inversion loop to connect them. So as you can see, one of them has to kind of make a flip in a loop in order to match up all these loci. So a crossover event, so I like to think of crossover events as I use my two hands. So each hand represents a chromosome, each finger is a chromatid. And when you put them together like this, you have a top and a bottom, which aren't touching anything, and the middle two, which are. So the middle two are the ones that are sharing genetic information. These top two will keep their genetic information. So we'll use that going forward. So what gametes can form between a crossover from the J and the K region? So first, we're going to do the easy ones. The top and the bottom finger are not going to swap any genetic information. So we're just going to go right along the lines. And so it'll be a MIJ. For this blue line, it'll be a MIJ, centromere K, L, H, and G. And then same thing for the red one. We're going to just have a MLK, centromere J, I, H, and G. So when we get to the crossover, we're going to have an M and I, a J, we're going to cross over, centromere, crossover, K, L, and M. And so this has a duplication, so this is not going to be viable. So then we're going to go on to our pink line, and once again, we're going to see it's not viable because of this. G, H, going to go around the loop, I, J, centromere, cross over to K, L, H, and G. And once again, we have duplications and deletions, which we cannot have. So these are not viable. So 2 out of 4 of his gametes would be viable. So chromosomes will match up to maximize their pairing. So once again, we're going to have another sequence, MIJ, centromere K, L, H, and G, and basically the exact chromosome, but reversed. So when these chromosomes line up, one is going to have to flip around, which I already did here, so they match up perfectly, no loops needed. So when we see what gametes would form from the crossover between them, we're going to do our finger trick again. The top and the bottom, so our blue and our red, are not going to swap any information. So these are going to be perfectly fine. They have all the information already, so both will be viable. But when we get to these crossovers, we're going to have to check it out. So we'll start with the green one, MIJ, centromere, crossover, K, L, H, and G. And you can see that no information was gained or lost. So this is perfect. And once we do it again, MIJ, centromere, cross up to K, L, H, and G, perfectly viable. So this guy has 4 out of 4 viable gametes. So which of these individuals has better fitness? Organism 1 produced 2 out of 4 viable. Organism 2, 4 viable. And organism 2 is more fit because he's able to pass on his genetic information much easier.